seeing now, these are metals that are naturally present in basaltic lava combusting. Iron, titanium, for example. I will show you a few lava formations today, starting with Pele's hair. Pele is the Hawaiian goddess of the volcanoes, and this is her hair. In nature, this forms when liquid lava falls over edges, cools down rapidly. It can also be from lava bombs that fly through the sky and are being stretched out, and then these thin strings of lava cool down rapidly and solidify, and they darken in color. But even when they are thin and they are darkened in color, you will see it will remain quite flexible, and they move a lot and look a lot like hair. This is a very common lava formation in Iceland, and it's beautiful. The lava is already reaching the bottom of our lava slide, and you cannot see it very clearly maybe, but here on the top it's not moving much anymore. So the lava, which is longest exposed to the colder air in the room, solidifies first. So that top layer is now quickly solidifying, and it's also acting like an insulation layer for the lava below. So even though here on the top it doesn't seem to be moving, there is lava flowing underneath and still coming out here at the bottom, as you can see, and it will for a minute or two more. I have 3 Hawaiian words for you today that are used internationally in volcanology. The first one refers to this slightly darker wavy pattern that you can see mostly on the sides of the lava flow. It's called ropipahoihoi lava, and this forms when liquid lava moves under a layer of lava that has already solidified a little bit, and that movement creates a ripple effect on the top layer. Now, I'm gonna have a big piece of ice here. I'm gonna put it on the lava so you can see this interaction a little bit more between lava and ice. So you can see a lot is happening. The water is rolling off of the surface of the lava as fast as it can. The steam is making bubbles sometimes, and the bubbles, they will inflate hollow spaces in the lava flow. The black lava is where most of the ice and most of the water is touching the lava. There, of course, it's cooling down much faster. And that lava is actually already under half of the temperature that the lava had when it came into the room. Don't worry about the bubble. If it breaks, it's not going to pop or pieces fly away. It will just deflate. Don't worry about that happening. So the steam will disappear, or the sound also as well. And once the steam sound is gone, you will hear a lot of crackling. Do you hear that? It's like a fireplace. And I guess this will qualify as such. If anything, it would probably be this. And this crackling is the lava flow which is cooling. When it cools, it shrinks. It takes up less space than it did when it was hot. This creates little fractures. These little fractures then join each other, creating not so little fractures. And the lava flow actually splits and segments itself in separate parts. That's going to get a bit loud from now on, here where the lava is lying on a piece of steel. So if you hear a loud bang like this, don't worry, it's because the lava is fracturing here on a piece of steel instead of on the sand here. Here the lava flow is round in shape, more or less. The outer edges of it cool down first, and then the inner center part cools down last. Even though all of this was liquid just a few minutes ago, the lava, or at least the outer edges of the flow, have now solidified so much that I can get under the lava flow and lift it. You see, it has already become one big piece. And I'll show you what the bottom and the inner part of the lava flow looks like. Here you see I can very easily pull out some of that beautiful mozzarella cheesy lava. It's not an Hawaiian term, but I think it's pretty descriptive. You can see how good the lava is at insulating itself and how much longer the lava inside stays orange and bright and syrup texture like. Beautiful stuff. The thinner parts here, I will hold it up like this, you will see that it will darken in color very quickly, so that means that it's solidifying. This is a volcanic glass called tachylite. It's very common. It's also very fragile. So we have about 40% silica in this material. Normal glass, so also the glass, for example, that glass-blowing artists use, is much richer in silica, about 70%. And it's the silica that makes it tough and hard. So for them, when their material cools down, it will stay in the shape that they formed it in. But for me, once it cools down, it's going to get extremely brittle and fragile. You can hear it cracking on all sides. I'm going to try to get the rod out without breaking it. And that really doesn't happen often. I rarely manage to do that. It always breaks when I get away from it, but now it stands up, so that's really nice. I'm sorry, I'm just going to take a picture and make my colleagues a bit jealous. 1 second. I want a picture of this one, it's a pretty one. So this will take a few minutes, but then it will get also very dark in color, and don't be surprised if this, while we're looking at something else, is just suddenly collapsing in, there we go, many pieces. It's because it's cooling down, and that's what happens with all the lava. Eventually it's going to break and shatter, and that's why we cannot do so much with this lava, except from the lava show, which is of course already very nice, but it really is not the same as glass, even though this is called a volcanic glass. This bubble, you can see it's transparent. We can look inside, and there we see that the lava is still very hot. So that little thin layer of the bubble traps a lot of the heat. It's very thin. I can very easily puncture a hole on the outside, and then I will put some paper in there so you can see how quickly that ignites and how warm it is in there. You see, that's instant, so that goes really quickly, and then we have a little lava lamp. And I love lava lamps. I think they're very pretty. In nature, you rarely see a lava lamp, although the bubbles are very common. And in nature, they are mostly inflated by sulfur gases. Today, for us, it was steam from the ice. That's also possible if the lava flow runs into ice or water in nature. Then you can also see that. So here in the front now, everything is solidifying also very quickly. Don't have much orange color left. It's mostly black now. You see the whole front has become one big plate. So I can lift this part of the lava, and then underneath you see that the heat is trapped there. It's still very red and orange and glowing. So the sand is very isolating. So that heat on the bottom of the lava flow, it cannot really go anywhere. It's going to stay there for a really long time while it cools down. If I were to hold it like this, the cold air that now has access to it will make this really brittle, and it will fracture and break within 1 minute. But I'm not going to wait for that to happen, because that's when usually pieces fly away. And this stuff is definitely close enough to you already. Now, those open hollow spaces in nature are the main reason why you hear that you should never walk on a young lava flow. And I'll try to tell you what a young lava flow is. If we leave our lava flow like this, it will take 3 days roughly to cool down to room temperature. In nature, a big lava flow will easily take 200-300 years to cool down. It's an extremely long and slow process, and at least a few decennia after the eruptions stop, hollow spaces like this will be extremely hot. And if they are close to the surface, they're very fragile. Our weight can be enough to puncture the ceilings of those open hollow spaces. And you don't want to fall inside. At our most recent eruption site, close to the international airport, we had liquid lava there still in September. People are already walking on it. That is way too soon. It will take at least 5 to 10 more years for those lava flows to cool down enough to be considered safe to walk on. We are of course not going to wait for 3 days for this to cool down. The next show is tomorrow at 11. So we better clean this up somehow and get ready for the next show. We can already do that right after the show. All of it will be completely black in color, very brittle, and then with tools like this, we just break the lava. So this one will be really easy. I'm just going to touch it, You see, and it falls into many, many, many pieces. I love that sound. You see here also, I just touch it a little bit and it all very easily breaks. I'm gonna make a few fractures here because the fractures will let some cold air in between those larger pieces, and so it will cool down much faster. Here in the front, you see, quite easy. I just drop this and then creates some fractures. Very easy. And then we have these smaller pieces. You can see how nicely the heat is focalized on the thicker parts of the flow. So of course the thicker parts will take longer to cool down. We call these medium rare cooked pieces. And that's my favorite pieces. I think they're beautiful. And then with a steel bucket and shovels, we bring this material in the back, and then in the back we can put it in the furnace again. So we can reuse it for the next show. So I'm not gonna lie, this is very experienced lava. It has done its trick quite a few times. Alright, I'm gonna show you a little lava tunnel. And we have a little lava tunnel here today because I punctured the bottom of the flow to show you that mozzarella cheesy lava. In nature, there's many reasons why lava will flow out of its encasing and leave behind an open, hollow space that solidifies as such. I don't know if you can see that. Do you see that hollow space below? I'm not sure what you're seeing. I'm gonna show you like this. That's better. So you see there's like an opening, like a river on the center there. So that's the ceiling part of a lava tunnel. This is a very small one, of course. In nature, here in Iceland, we have some that are really big, 5, 6, 7 kilometers long. So lava tunnels can be really, really big. And in Iceland, you can even walk inside of them with a guide. You can visit and walk through. It's absolutely beautiful. I highly recommend that. It's very pretty. And in Hawaii, we have the longest ones in the world. There they can easily be 50, 60 kilometers long. So they are very big, intriguing parts of lava flows. And this material is basalt. This is a common form of lava in Iceland. 75 to 80% is basalt. And here in this room, we have 3 forms of it. The sand, this you now know, it's pulverized lava from Katla, and we have initially melted that and put it in the furnace. And then we have the lava flow itself. And thirdly, we have these basalt columns as decoration around the slide. Believe it or not, this is exactly the same material as these 2 other forms of lava, but it has had the chance to crystallize in nature, and that's why it looks so light in color. It's also much denser. Here, this is a much nicer lava tunnel. There you get the idea a little bit more. So you can see that big open hollow space there on the inside where liquid lava used to be, and then it flowed out and it left behind that nice glowing open hollow space. Now, before I continue, do you have any questions, anything particular that you may wonder about that I haven't mentioned yet, anything that doesn't make sense? I will also stay here. Yes? This? Oh, nice question. I cannot give you an exact number, but this will take a few hundred years to cool down and form in such a way. Let's say 200-300 years, something like that. This is what will take the longest in the lava flow to fully cool down. Yeah. Okay, everybody, little surprise for you. Would you like a little souvenir and take a piece of this lava flow home? Yeah? Yeah. Well, that's great because there's plenty. Help yourselves. Okay. No, we're not gonna do that. Way too hot, way too sharp. We would cut and burn our fingers simultaneously. But Delphine, who is the one who made this beautiful lava for you today, he will come in soon to open the door. He has been nice enough to select some pieces for you of a show from a few days ago. Definitely cooled down. But remember, it is a volcanic glass, so it is sharp. Please don't squeeze it or rub your fingers too much on the edges. And if you put it in your back pocket, remember that it's there. I made the mistake a few times myself, and I don't want you to learn the hard way. So if you stick your hand out flat to us, we'll put a piece on your hand, and then you have a little souvenir from Iceland. So this is tachylite volcanic glass from Katla. It's basalt lava. It looks a lot like obsidian. Some of you may know this as dragon glass from Game of Thrones. It's not exactly the same stuff, although it looks very similar and it forms under similar conditions as well. But our tachylite glass, it's like normal glass, it has much less silica. So we have 40% silica, obsidian dragon glass has about 70% silica. So that is a much tougher, harder material. It is used, for example, to make jewelry and weapons. Sorry.
How long before you can actually pick this up and put it back in the furnace?
We can do it right now. Yeah. Since we use tools, we don't directly touch it, so it doesn't matter that it's still really hot. Yeah. I can tell you how hot it still is because we have a heat gun. I can point it at the lava to tell you the temperature. You see I have some laser points. I'll point it first at the black lava here in the bubble. Here it's still 460 degrees Celsius. I'm going to try to find some orange lava. There's almost 700 degrees Celsius still, so half of the temperature that it had when it came into the room. So it's still really, really hot. But yeah, it doesn't matter because we don't really directly touch it anyway. And especially now, this is the last show of the day, we will just leave this until tomorrow. Yeah. So, you can still hear the lava cooling, still cracking, fracturing. It's not impossible that another piece flies away. Please protect your eyes from that until you're at the door. At the door, you'll find a bowl where you can put your safety glasses back in. Don't hesitate to leave us a review somewhere online. We hope you had a good time. I sure did. I'm sure Delvin did as well. And also on behalf of Delvin, thank you so much for coming to the show. Have a good one. Thank you. Thank you very much. Cheers.